This video goes over the inventory simulation in the textbook. The simulation is built around a hypothetical company, Butler Internet Company, which distributes wireless routers. We're provided with some information regarding the company. If you don't have your worksheet set up like this, you'll want to pause the video and set the worksheet up. Notice I've let some of these fields just bleed over without extending them, trying to keep these headings in mind. So, for example, the labels here are in column A, but the values will be in column C. Column B isn't used. You want to try to put things in the same cell if you want to use my cell references as a point of reference. Otherwise, you can set it up however you want. We're provided with some information in the text. They do a gross profit calculation based on the selling price and the cost, and they come up with a gross profit of $50 per router. So I'll put that here. Then we have costs associated with ordering too many, so holding costs, and costs associated with running out of stock or stock out shortage costs. We have a holding cost of $15 per unit for every unit we don't sell. We have a shortage cost provided in the text, a loss of goodwill in the form of $30 per customer, as we have to turn them away because we don't have product to sell them when they want to buy it. We have a replenishment level of 100 units per day. That means that we restock to ensure that we have 100 units in stock. So if we have 10 left over, we'll order 90. If we're sell all 100, then we order 100, but we keep our inventory at 100 units. The demand follows a normal distribution with a mean of 100 units and a standard deviation of 20 units. With this information, we'll go ahead and set up our simulation. They want us to simulate this model to 300 months. So we're looking at monthly transactions here. We'll do that, and then we'll come back and we'll cut it back to about 10 periods so we can do some calculations and show you what questions on the test might look like. Again, to populate the number of months, we'll put a 1 here, and then we'll go to our Home tab, and we will select Fill and Series. We want our series in a column. We want it to step one value at a time and go to 300. That will give us a series 1 to 300. Now I want to calculate our demand, and we're given the demand distribution here. It is normal with a mean of 100, a standard deviation of 20. We're going to use the integer function along with the norm inverse function in order to remove the effect of decimals on our demand level, since we can't have a fraction of demand. The text, they don't do that. They talk about the problems associated with leaving decimals in there, but they don't really do anything about it. And I want to just introduce you to the idea of one way to solve that problem. So I'm going to go ahead and use my norm.inverse function to get the level of demand, but I'm going to make that value an integer. So I'll use the integer function and then the norm.inverse function. The probability will assign the probability at random based on a distribution with a mean of 100, and I need to make that absolute because I want to copy this, and a standard deviation of 20, and again absolute because I want to copy this down. Then I want to be sure to close off my integer function with a parenthesis and press enter, and there we have a value at random. Again, your value will not match my value. These are generated at random. Now, to calculate sales, we have to take into account the idea of a stock out. And the common function used when there's a stock out possibility is the minimum function. In the minimum function, we want to take the smaller value between demand and our replenishment level, or the number of items that we would have on stock. In a bakery, it might be how many biscuits we baked, but in this case, it's how many routers we put on our shelf. So I'm going to use minimum, and then I'll look to my left and leave that relative. And I'll look to my replenishment level and make that absolute. What that means is if demand is less than 100, then we only sell what's demanded. So if demand's 90, we sell 90. If demand is 106, we only have 100. So we can only sell 100. We don't have 106. So we take the minimum of those two values, and that's our sales. See, demand here's 142. We sell 100. Gross profit is going to be what we sold times the gross profit per unit. So we'll take our level of sales for that period and multiply it times our gross profit per unit. We'll need to make that absolute. Now for holding costs, we need to look and see if we are holding any. If we're holding some, in other words, if demand was less than the replenishment level, then we had some left over. So we're holding them. We need to multiply that value times the cost for holding items per unit. Otherwise, we put in a 0. So I'm going to use an if function here. I'm going to take a look to see if demand was less than the replenishment level. If demand was less than the replenishment level, and I'll make that absolute, then we have a holding cost. So I'll take the replenishment level, since I know it's larger, make that absolute, and I'll subtract from it the demand. Once I have that quantity, I'll multiply that quantity times the cost for holding, which I need to make absolute. Otherwise, there's no holding cost. I put in a 0, close off my parenthesis for my if statement, and I have no holding costs. In this instance, changes each time I press enter. Now the shortage cost is very similar. I'm going to take a look and see if my demand was greater than the replenishment level or my inventory level. If it is, then I ran out of stuff. More people wanted to buy stuff than I had to sell them, so I incur a shortage cost. And my shortage cost is going to be my demand, because I know it's the larger value. That's that quantity. So I'll take demand minus my replenishment level, which I will set to absolute. Again, I want to copy this. And I'll multiply that times my shortage cost. And again, I'll make that absolute. Now, if it's not, then there was no shortage cost, so it's 0. Close off my if statement, press enter. There you go. And you can see it works here. I have a shortage, a holding cost. I had demand of 80, so I sold 80, which means I had 20 left over, and 20 times 15 is $300. So there you go, no shortage. Now my net profit is simply my gross profit less any holding costs less any shortage costs. There we go. Now I've done the calculation. I simply select these values and double click my autofill node, and it will automatically fill down to 300. You can see here, I'll just jump down to 300. There we are, 300, and that's row 316. back up here to the top. Now I'll do the remaining calculations. So I'm going to calculate the average profit with a mean profit value. And we'll make that average. And we know that our range of profit begins at G17 and it goes to G316. Standard deviation, we'll use the standard deviation of the sample, and that starts at G17 and goes to G316. Our minimum profit, we'll take the min of G17 to G316. Maximum profit, we use max, G17 to G316. Now in the text, they ask us to calculate service level. What they mean by service level is to what extent are sales servicing demand given this replenishment level. And so we would perhaps change this level if we were doing some modeling to try to find a replenishment level that provides a higher service level over time. But the point simply being that I need to calculate total demand and total sales so I can put sales over demand in order to get the service level. So I'm going to calculate total demand. That'll be sum of my demand column, which is B17. Oops, 17. B316. And sales, which is the sum of C17 to C316. And equals, I'll put sales over demand, and that will give me my service level, 92%, essentially. Well, that's how we set that up, but in an exam, I'm going to want you to set up your model, and then I'm going to give you, let's say, 10 months worth of values that were generated at random. In this case, demand was generated at random. So I might say, okay, here are, for example, 10 months worth of demand figures. Place these here. So you go ahead and maybe redesign the model. Let's get these out of here. In the exam, I'd probably just have you make a model that went down to 10 months. And take these values and just copy and paste them right over the demand values. And then if you've set this up correctly, you'll get, we could go in and change all of these, but they're going to work okay. Let's change them though anyway. It goes now, instead of to 316, it goes to 26. It's only 10. 26, you can see that's the same value as standard deviation. Same deal. 26. 26. 26. 26. 26. And then that would be the same. Now I can ask you things like, what's the mean profit? What was the max or the min? I can ask you, what was the net profit for period 6? I could ask you, what's the holding cost for period 3 or period 2? I could ask any question and we'd have the same answer, but you wouldn't have them right if you hadn't set up all of these calculations correctly. Then I might ask you about this calculation that we did in the earlier model, the norm inverse, and give you a multiple choice question and say which of these formulas did you use to calculate this? And I'll give you the norm dot inverse. I might give you the formula for a uniform distribution. I might give you a VLOOKUP for a discrete probability distribution table. And then you'd have to pick the right one. If you pick the wrong one, then I know that you couldn't have calculated this cell. That's pretty much the way we're going to run the exams. So that's how you complete the Butler inventory model, and then that's how you would use one of these models in an exam situation in order to provide the correct answer. And that goes for homework also. So if I give you homework, I'll probably give you some fixed values to put in there, and then for the homework, I'll ask you similar questions designed to kind of get you ready for the exam. That's how you do it.